Hello and welcome in this video where we'll speak about trends. So first I have to say that there is no well-defined notion of a trend. There is no definition, okay? But there is an intuition. A trend should be a long-term underlying movement of the time series. So for example, here we have a time series, here. Okay, so we have a time series and we see that it is increasing. So it looks like this time series has a trend. So we can plot this trend here. Okay, but and this trend here is nothing but the regression line. Okay, and this regression line we saw several times how to compute it. We know how to compute its slope and its intercept. Okay, so this is there is nothing new here, but the fact is that this trend might well be just an illusion. So let me just explain that by showing you how this time series has been constructed. Okay, it has been constructed by just choosing random numbers and summing them up. Okay, it's a cumulative sum of a list of random numbers. So this trend that we see here is in fact essentially inexistent. Okay, it's not a phenomenon. It's just something that we observe but has no real meaning. It's not easy to explain, but there is something very interesting to understand here. We have a purely random sequence, and we seem to think that there should be a trend, that we could explain something with this trend, while there is nothing to explain, in fact. So we have to be very careful with the notion of trend. Okay, but it can happen that the time series we are sorry, so I forgot to say. Let me just show you the sequel of this time series here. If instead of 1000 terms we take 5 millions of terms, what we obtain is this thing. So we see the beginning of the time series here, and then it continues by growing, decreasing, increasing, decreasing. There is no real trend. Okay, so now it can nevertheless happen that for some reason the search for trends seem legitimate. So in this case we need a tool to find these trends, and here we will use neural networks in order to find trends. Okay, so let us come back to the example of the GDP of Spain. Okay, we saw how to plot this time series here, and we won't be interested in the last part here. We will just be interested in the first part before COVID. Okay, and what we observe is that at the beginning here, between 1995 and 2008, it is increasing. And then between 2008 and 2014 it is decreasing, and then from 2014 on it is increasing again. So we might have the idea to search for a first segment here that would be an approximation of this curve, then a second segment here that would be an approximation of this part, and a third segment here that would be an approximation of this part here. Okay, and so we would have a broken line with 3 segments. All right, so it's not easy to find these 3 segments, but here I'm gonna show you how we can do that by using a neural network. Okay, so the function, I won't describe the function, but not in details, but it's here on the top of the file, sorry, here. Okay, we will use this function here. Okay, so you can have a look at its implementation, but it's not the object of this lesson. So let me come back to our example here and show you how to use it. It's very easy. Okay, so we will use the function deepLearnApprox that you can use whenever you want. Okay, we need to give it a time series under the form of a data frame. Okay, so the index column has to be in date-time format. We have we give the name of the column we are interested in. Here it's GDP. Okay, and finally we give the dates where we think the extremities of the segments are. Okay, so here, for example, the first segment should begin at the left, so this date here, and go to approximatively here. Okay, so 2008. So we give these dates here, and then the date of the next break in the broken line, which would be here, 2014. Okay, and the last one, so it's 2019. So we just give the dates of the breaks in our broken line, and then the function will search for the best possible broken line that approximates the curve. Okay, so let me show you the result we obtain here. Okay, so here it's just plotting. All right, so here we have in yellow the starting broken line. So we gave these dates here, the date of the first extremity here. Okay, we gave the date of this break, the date of this break, and the date of this extremity here on the right. All right, and what the function did was to search for a better approximation by using gradient descent through the use of neural networks with ReLU neurons. Okay, and it found that this green line is better, the best possible broken line to approximate the blue curve. Okay, so here we have the weights at start. Okay, so the weights in our neural network. Here we have the weights at the end, so you see that it changed a little bit. And here we have the error, the cumulative error at squared, the mean squared error at start. Okay, so for the yellow broken line, and the error at the end once the neural network is trained. Okay, so as you see, we have an error that is sensibly smaller. Okay, so this is an example of a use of machine learning in the study of time series. Now let me just add that here we defined the step h, okay, the learning rate eta, okay, and the number of steps in our training. Here it was 1000, okay, but maybe we can think that this training is not finished, so we would like to train the neural network for a longer period. Okay, so we can do that as follows. We take the same function, okay, and we use the weights we obtained from this training here. Okay, so these weights we obtain them by using the key weight stop for the result of this function. The result of this function here that I showed you is a dictionary. Okay, and in this dictionary you have a certain number of keys. So we have approx stop, approx start, norm data, norm factor, error start, error stop, weight start, weight stop. Okay, so at the beginning, when we give these values here, we have it's a way to define weight start, but this weight start won't be used. These dates won't be used if we furnish the value of weight start. If we furnish the values of weight start, the training will begin with the weights we gave here. So it's what we do in there. Okay, we take our time series. We give dates, but it's useless here. Okay, but we define the weights. The weights are W. This W is the result of the previous training. Okay, and we can start the training from this point on with different values of h and eta and n steps if we want. So we did that, and what we obtained was almost the same result. Okay, so this means that the training is almost finished. Okay, we have a very good result here. All right, so finally I want to show you that we have to be careful once again with these questions of trends, since here, for example, we have a completely random cumulative sum in blue here. Okay, and we can do exactly the same and obtain a result here. Okay, a broken line with two parts, and we could be tempted to explain something with these trends here. Okay, but as I mentioned before, these trends cannot explain anything, since there is nothing to explain in this case. All right. So it's finished for this video. In the next video, we will speak about seasonality.